Hello everyone. Let's start the session. So pick up headphones and let's start. Can you hear me loud and clear? Perfect, thank you. Today there will be no Q&A session live, so if you have any question, I will be here after the talk so we can discuss any use case, any question, so feel free to come to me after the presentation. And today we'll be talking about how my team created the authorization for enterprise organization with Amazon verified permissions and CDAR. I am Daniel, I am AWS security hero and one of the early adopter of CDAR and Amazon verified permissions. So let's start. So this will be use case of the enterprise organization Simply Business. It's one of the largest UK insurance broker. It provides fast, flexible cover for small businesses and landlords, and it's highly regulated industry. So during the talk, you will see like what challenges we might have with that and how we can solve that. And all of our workloads operates on AWS. So about Simply Business. Simply Business believes in the full power of small businesses. So they providing for them customized insurance policies, so they can just focus on growing instead of having any worry about any potential risks. So about our organization, so with enterprise organization, we have over 100 developers on board. Developer experience is very crucial for us. We have multiple monolithic apps written in Ruby, so most likely Ruby on Rails framework. We have millions of requests per month, so you will learn how we started to authorize those, as well as our infrastructure as code is Terraform, so you also will see some examples. Let's continue. So authorization. Today I will cover three main topics. So first of all, the external role-based access control, which we called gateway access control. It will be about the API gateway authorization. Later on, we'll focus on internal role attribute-based access control, which we called resource access control. And the last part will be about internal role-based access control, so service access control. So before we jump into the implementation of that, let's focus on CDAR and AVP itself. So for you, CDAR is an open source policy language. So you can define your policy when you can permit some access, forbid some access. It's written in Rust, but don't worry, it will be nothing about the Rust on this session. Once you define those policies, access policies, CDAR is also about the policy evaluation. So once you define it, you can run it and check whether can you be authorized or not. So it's providing both the possibility to create those policies and also to evaluate them, because there is also authorization engine under the hood. And it's very easy to analyze. The syntax is pretty nice compared to some other solution on the marketplace. So the basic syntax of CDAR is like follow. First of all, we have the effect. So it's either permit or forbid. It's also deny by default. So most likely, you will just define the access policies to permit something. And it's very similar to IAM. Then you need to define the scope, so principal, action, and resource. And in the end, you can also use conditions. So when some extra condition needs to be fulfilled, then you can use it. And you will learn it in practice in a second. And now about Amazon verified permissions, because you might think, OK, Daniel, CDAR is written in Rust. I don't know Rust. I will not learn Rust just to make authorization. And it totally makes sense. So it's Amazon verified permission. It's managed service from AWS. When in the management console, you can manage your permissions. You can test those. And then from the application, you just use SDK or API calls to authorize. So easy as that, like typically with any other AWS service. And it's quite young service because the GA was June 13, 2023. We started working with AVP shortly after the GA. So you will also learn what is missing, So in AVP, there is a concept of policy store. You need to think about it of like container for policies. So you create multiple access policy, and when you would like to authorize, you make a request against this particular policy store, so against this container for policies. You don't need to learn Rust because there is SDK. There is a test bench functionality. Once you define your access policy, you can test it in the AWS console, so test whether the policies are OK based on the different circumstances and payload which you will send into that. And now the crucial part of AVP is schema. So what is this? So it's a JSON data structure. So it's designed and created for validation of all attributes. You will have entities, relationships, data types, which you will send during the authorization request. Moreover, it's also the validation layer for access policies. So if the schema we define some attributes, that those need to be required. So if we later on create the policy, it will check it automatically during the policy creation. And it's also documentation for other teams, because if you switch between the policy store, you can just check what entities it has for this particular authorization, and it's easier to like verify it and check what is going on. And in the end, in AWS console, it will look like this because it's a JSON, and in the AWS AVP console, you will see just the visualization of that. Now the policies. So we have two types of policies in CDAR and AVP. So first of all, the most basic one is static one. So you just hard coding the values. In this particular example, we can see that we allowing any principal to read any resource when the principal name is XYZ. And also we have the second type of policy, which is the template one. So you can see the question mark next to the principal and resource. It means that we can dynamically later on pass those attributes to link the parameters into the template. Quite useful. And the last part, which is the most confusing when you will start learning AVP and use it, because let's assume we have access policies, we have the schema, we making the authorization request. We require that the principal name should be XYZ. But how AVP will know that your principal has this parameter? You need to send it into AVP during the authorization request, because AVP does not have database. So you need to construct the payload when you provide information about the principal, resource, action, relationships, data types, and so on. So if you forget to pass it, most likely your authorization request will fail. You will be not authorized to do anything. Now, quickly about the first scenario, so external role-based access control. So problem we had was that we onboarding partners so they can use our APIs. So as the front door is API gateway, and then after it, the request is redirected into the application, and we were doing authorization over there. However, having multiple applications means that we have a lot of duplication of those code, and we would like to change it. So eventually, we wanted to have the role-based access control on the level of the API gateway. So on the front door to add the authorization layer, so we don't need to do it on the resource server level. So what we've done, so the challenges was that we have repeated authorization across multiple applications. The authorization was only on the resource level, and the goal was to centralize authorization, just to have one place for the authorization for external partners. Plus, we wanted to have authorization just on the gateway level. So how we use it? So we attach Lambda authorizer to the gateway. So each time the request will be there, so the Lambda functions invoke. So it's making authorization request from the Lambda to AVP. And as a response, we will obtain authorization decision. So based on that, we can enforce whether the request is authorized or not. So with this solution, we did get rid of the authorization from the resource server, and it's only on the gateway. So how to authorize? Because you might think, okay, so what attributes I really need? So first of all, we have some partner. So it's our identity, partner A, B, C, and so on. And we have resource, which is API endpoint. And the actions could be, in our use cases, either to get some information or post some information. So for the action, we have just get and post. So if we think about the schema for that, it's like this. So we have principal as identity, two actions, and the resource. And we also have the relations of role that identity has role. So based on that, when we have the schema, so we need to create some access policies. We decided that we can create two templates, one for the action of get and the second for post. So we create the template, and based on that, we can link the parameters into the template. So you can see in this example that principal with role partner A can get this particular endpoint. As you can see, there is some learning curve of CDAR, because if some developer would like to add some authorization, we need to add this information. So somebody needs to learn CDAR, create those templates, create those parameters, like how in case of the developer experience we can improve it. So what we've done, we created the configuration JSON. So we just ask our developers to add the endpoint and role. And based on that, under the hood, we map it into the Terraform configuration. So it's fetching information from the JSON, and then it's mapped over those files and create the template link policies for us during the CI/CD process. So with that approach, is much easier. And in the end, we'll obtain the same result in AWS console. So just add one key value into the configuration, and that's it. So how we can be sure that our policies are OK? Because we open the pull request, there is a new policy added. So how to test it? So we can manually test it in verified permission test bench. But this manual process, it will take a lot of time if we need to add a lot of endpoints. So we just added the release test to the rescue. So we just prepared multiple cases, both for allow and deny. And during when we opening the pull request, it's running automatically. So first we deploying to integration some policy store, then policies, and then we run the release tests. And the example is like that for deny, we're just checking a lot of different endpoints, and we adding some attributes into it, and with different roles, and also for the allow will be similar. Cache is important. So luckily, if we have API gateway, we can easily use the cache functionality that it will automatically cache data from the gateway. So we don't need to necessarily each time making requests to Amazon verified permissions. So as a cache key, we just need to set up the access token, HTTP methods, and resource path as a cache keys. And the TTL is for 10 minutes, which is sufficient. And you can see the New Relic logs that for the cache one, it just took 8 milliseconds. And you might, and with that approach, we can cache up to 70% of requests in our use case. And you might think, what about the latency? So for us, it's typically between 25 milliseconds to 40 milliseconds just for the call to AVP, which is acceptable. And also what is important for us as Simply Business operates in regulated industry, so the audit. So luckily, there is support for CloudTrail. So in CloudTrail, we can see all operation from the policy store, whether somebody added a new access policy, whether it was deleted, whether somebody changed something in schema, and also all requests into the is authorized operation from the SDK, which is pretty useful in case of the regulations. So the lesson learned from that, so we implemented role-based access control for developers without learning curve of CDAR. Obviously, we needed to learn it upfront. Second thing, release tests are very useful. And it was quite easy to implement this authorization because it's outside of existing code, because it's just the Lambda function. So whatever language you use, framework, it's like something next to it. So it's very easy to implement it and make it to the production very quickly. What was not great is editing policies, because you saw the final effect of this linked policies that we giving access to a particular partner with specific role. But if you would like to edit it, it's impossible. You need to delete it and then create a new one. If you use infrastructure as code, so it will recreate it or will do it better instead of deleting, waiting a couple of minutes because it's need to recreate it. So if you would like to edit existing one, my suggestion is to first create a new policy and then delete the old one. Hopefully one day it will be fixed, because it should be done under the hood by the AVP itself. And there is also no blue-green deployment for verified permissions, because once you add the policy, it's live. So you need to first test it on some integration, maybe on staging. So there is no real functionality of blue-green deployments in AVP yet. And now let's talk about internal attribute-based access control. So recap from the previous one was that we have the gateway. So now once we have access through the gateway for external partners, now they can access our applications, but also we have some internal traffic. So what we need to do now is to give access based on the attributes. So if somebody would like to renew insurance policy, so based on the attributes they will send, maybe we should not allow to do it because some attributes could be missing, or it will be some wrong type of the region and stuff like that. So how we can authorize such a scenario? So first, again, in case of the principal, we have some partners, so our identity, and also we have some internal identity, so could be some application name. Then the resource. So in our case, we have three types of resource. First of all is RFQ, which stands for request for quote, policy, and external policy. And what action we can do is like, as partner, I can read policy, but also I can create a policy and also create existing policy. So what authorization attributes we have? So in case of identity is the name, could be like partner A, some internal name. In case of the resource, so entity type, RFQ, policy, and external policy. We have also vertical, whether it's professional, shops, compensations. We can also have some business unit, whether it's UK or US-based. And also the insurer, so partner A, B, and so on. So the original idea was that we will have just one policy store for all resources. So just three types of that for policy, external policy, and RFQ. And then when we started to think, okay, so how we can define our access policies? So the original idea was that how we can, like the original question was like, how we can distinguish which type of the resource is present during the authorization request, because we somehow need to distinguish it. So we checked the CDAR documentation, and we found that there is a is operator. So we can then implement it like this. So we can permit access, for example, to create resource if the resource is the particular type of the RFQ, and also we would like to check some vertical. It makes sense because with that approach, we just need to free access policies and we finish in case of the CDAR. Yeah, makes sense. But this operator is not supported yet in verified permissions. So you might think like, okay, I'm using CDAR, but not all functionalities are present in AVP, and that's true. Let's talk about it. So we learned that the hard way. So this operator was introduced in CDAR 3.0 version, and the current version of CDAR and for AVP are not the same. So for AVP is 2.4, and CDAR will be shortly on 4.0, which means that different versions, different functionalities. So lesson learned from that, what you will read in the CDAR documentation will not necessarily work in AVP. So you need to check on which version is AVP in the documentation. Then you can check the documentation for CDAR and check what you can use or not. When it will be available, the newest version, I don't know. And also you will learn that even syntax between CDAR versions in AVP and CDAR itself will be different. So we finish with free policy store with different resource for each and every policy store. And similar, like for airbag, we have identity, we have some action for create, read, and update. And for the resource, we have policy. And again, we have role. And also for policy, so the resource, we added the business unit and vertical as a string values. And now about the policy. So first, the most common one will be that we allowing for the particular action, like for the create. So what we have here, we checking the principal name, whether it's partner A. We also checks whether vertical are in this array of strings, and also whether the business unit is the particular one. We can also have options for checking extra attributes, like also checking for insurer. And also we need to check whether it's maybe just internal system, so we don't need to check those attributes because it was already validated upfront. So now about the code, because the challenge here that we have multiple resource servers. So we have server A, B, C, and like how we can add authorization to those resource servers, because it's not Lambda anymore, it's a big monolithic applications. Like where we can build the logic for communication with AVP, because it's not just making a request, we need to handle the request, we need to build the payload, and so on. And how we can reuse it, because implementing it 3 times for 3 different applications could be time consuming if we're doing it every day from scratch. So we created a gem. So in Ruby is a library which we can reuse internally, which is called SB authorization. So just handling authorization for us is easy to reuse across multiple projects, because it's just dependency to the project, and then it's just easier to use it. So we use hexagonal architecture for that. So it's also known pattern for ports and adapters. So it's just about making isolation for the main domain logic, and to not necessarily connect it directly into the infrastructure code. So like if we have some connection to the databases, some connection to the external API, so to just create adapters and reuse that and don't touch the main logic. So in our case, the main logic is just the authorization service. So any application will use it, just this authorization service. So whether we will use AVP or something else, we're just switching adapters, so we don't need to rewrite the whole application over and over. So we created 2 adapters for the beginning, one for verified permissions, which will be handling communication with AVP, and the second one, the mocked one, just for some test purposes, which always return allow. In case of the authorization decision, we also have some layers of configuration for payload build, and also for some configuration, plus also for the cache and logger, because maybe you could or want to use some different cache, maybe some built-in or maybe some Mongo one, or with Elastic Cache, Redis, and so on and so on. So the example code is in Ruby, but it's very simple language, very close to the natural one, so you can easily understand it. So first of all, we need to have some AVP payload builder, because it requires the specific attributes. So you need to map over keys and just create it, also pass the policy store ID and so on, filling information about the principal, action, resource, and entities. And later on, you need to build the adapter for AVP. So First, you need to build the payload, you need to send the authorization request, you need to handle the request if it's failed, so to raise some exception, rescue it. Also, later on, you need to handle the authorization decision. So there is some involvement of creating code. Later on, the mocked authorization adapter, because you can also see that those are reuse the same interface. So if we use it later on, we just can switch easily between the adapters. So how to use it in our reality? So once we have this gem, we need to have some authorization adapter for the resource server, so all those will communicate with authorization gem. So how to use it in action? So we have some resource server A with authorization adapter. So we have our gem. So inside we have a public method authorize and also some public entities which we can fill to make the authorization request. And under the hood, it's calling verified permissions adapter. It's also calling payload builder. And in the end, it communicates with AVP to obtain authorization decision. And also some example of this adapter. So we first need to build the identity, action resource, then call the authorization service and pass this information. And then based on that, return the value. Yeah, easy as that. And also for the resource, we need to check whether it's the proper one. And testing. So about the testing. So we already have the release tests for testing only verified permissions. So for the prepared payload against the AVP, but we also have some unit tests for building the payload and the whole flow. So we know that we first calling this method to build the payload. We expect that payload will be like that. That then if the AVP will return 500 errors, so we can handle it. But how we can check whether authorization request is valid? So like the only option, before we jump into it, so for AVP, we need to make sure that we have the schema as a starting point. Later on, that when we create the policies, that those are properly against the schema. So it's done automatically by AVP during the creation process. We also need to validate that the payload we built is against the schema. So all those attributes relationships. So how to achieve it? We can only do it by sending real requests to AVP, because there is no test capabilities for that. So we started to think about it like how we can do it better and make better confidence when we're building those authorization solutions. So what we found is CDAR CLI. So it's a CLI that uses the CDAR engine. You don't need to learn Rust to use it because it's just a couple of commands. We started to run it in Docker locally and also added into our CI pipelines. And what is nice about this, so we can run authorization requests against policies and schema, which means that locally we can test the whole flow. But it's also not such as easy that, okay, so the same code which we're using for AVP, we can just use in CDAR CLI and that's it. So, but the most important part, which is missing in AVP currently, is that we can validate payload against the schema. So we can make sure locally, even on the level of the unit test, that the request will be okay. So let's check the differences. So for CDAR, each request is stateless. So like there is no concept of policy store, like each time you need to send all those data because it's not stored in AWS. We need to pass files with our policies. As well, the policies need to be grouped together, and there is no split of entity type with ID. So when we created like the principal action resource, so all those need to be together. On the other hand, when we check the verified permissions, so schema is within the verified permission already, so we don't need to pass it. The same for access policies. We have different syntax because we have split entity type and ID. And we also need to pass the policy store ID because it needs to know which exactly policy store will be in used. So we ended up with creating CDAR CLI adapter. With hexagonal architecture, it was quite easy. So first we need to have another payload builder for CDAR, and then we need to map over all those files, build it the proper way CDAR CLI require. So still it required to write quite a lot of code. So in the end, we can authorize with using CDAR CLI. So you might think, so how now can I use it? Because if I don't use those from the AVP, so how can I reuse it? In our repo organization, we have all the Terraform files. So we just pointed to the schema path from the Terraform and also for the policies as well, which means that we have one-to-one what we have in AWS, we can do it locally. So in here on the unit level test, we can have our local AVP, which means that we can test the whole flow, whether we will be authorized based on the particular data, whether the payload is okay and valid against the CDAR, and so on and so on. And it very increase our confidence while developing authorization, because everything could be tested locally and then we can just ship it to production to use AVP over there. So now about the cache, because it's quite important aspect. So in our case, it's a combination of identity attributes like name, roles, authorization attributes. Also we cache based on the action attributes, resource attributes. So we fetching all those information, and based on those attributes, we create a unique cache key for that, and then we checking whether this particular cache key is already exists in our cache during the 10 minutes TTL. If yes, we just read from the cache. If not, we need to make a request to AVP. So to make the visualization a little bit better, so let's assume we have some cache. So we're making the first request, so the cache is missed, so we create a cache. The next request within the 5 minutes, so cache is hit, so we read from cache. And let's assume it's some different key, so it will need to make a request to AVP. We created some dashboards in New Relic to check what is inside. So we're checking what type of identities are making requests, success ratio, and also how many data are read from the cache. Like for ABAC, it's like 20–30%, which is quite good result. And now funny thing, because we're testing a lot on integration, we're making some integration policy store. And as you can see on our integration stage, we have almost 300 policy stores. And you might ask me how I can easily find my policy store. You might think, okay, maybe there is search functionality. There is no search functionality in AVP console. There is also not sorting, and it's all sorted through the ID, which is generated by AVP during the policy store creation. Moreover, the description part is just limited to 255 characters. So if you're creating through the infrastructure as code, so most likely you will add which region it is, which branch name, and stuff like that. So it's very hard to seek for the policy store. Some of you might think, okay, Daniel, so maybe you can use tags to check which policy store is there. There is no support for tags for policy store, neither for policies, which is also painful in case of the cost allocation, because we cannot assign those tags to the particular team. So all cost allocation of AVP is on my team because there is no tags, unfortunately. Hopefully one day it will be there. And also will be useful to check to which team it belongs to in case of any modification in future. So it's very hard to seek for the policy store. What we do typically, just seeking through the infrastructure as code outputs, fetch the policy store, open the first one, and just replace the URL with that. And now about the developer experience, because we discussed okay, how we can easily spread it across multiple projects. So first of all, we added Backstage template. So Backstage It's just the developer portal when you can create some templates which you can reuse across your organization. So you can open some pull requests with some pre-filled data files, and then you can make some condition if you would like to add option A, B, C. So we've done it. So we created authorization policy template for adding attributes-based access control. So what we have inside, we define which repo it is, what the authorization type we would like to add, which branch name, whether it should be draft pull request, and also what is inside is all the Terraform configuration, IAM, GitHub workflows, some shell scripts, alerts, some example CDR policies, release test, and some README, of course. So it's much easier to spread it across the organization. So lesson learned from that process. So CDR CLI is a real game changer in case of like developing it, confidence for local testing and so on. Hexagonal architecture is useful because, as you can see, originally we started with 2 adapters, then we needed to add CDR CLI, so we just added extra adapter. If one day we would like to switch to something else, just add extra adapter. Backstage template was quite useful, so it's easier to avoiding copy and paste over and over through the project because you always forgot to pass some particular file, so it's easier with Backstage. So what was not cool, so many differences between CDR and verified permissions. So starting from these versions, issues, then with syntax and so on, also the testing capabilities. As you can see, there is also a lot of code to just make requests to verified permissions because you need to prepare the payload, you need to make adapter for AVP, for CDR, and so on. And ABAC is much harder in many aspects because first you need to fetch some resources, then you need to validate it. It's not such as easy. That is not very first layer like for the role-based access control, unfortunately. And some of you might think like, okay, Daniel, so why you just don't use CDR CLI instead? Because it's like the same one. So why you need to pay for AVP if you're doing it for free with CDR? Well, the first thing is like auditability because a regulated industry. So it's much easier with that, and we don't need to maintain and CDR ourselves, whether it will be Lambda, ECS, or something else. Maybe one day we'll see. And now the last part, so internal role-based access control. So as a reminder, first we have some external partners on the API gateway level. We make the forward request to our application. Then we have some ABAC in place. And the last part is like role-based access control between application we have, because we have over 20 applications. So it will be nice if we have the process of renewal of insurance policy that maybe it definitely should talk to customer service application, but maybe not necessarily the risk assessment application should talk to customer service. So we need to enforce authorization on the resource server level. And also we have external partners, internal traffic. So it will be nice to have authorization everywhere, so to have zero trust policy in place. So what is the goal here? So have higher level of control. So if we have a single token to avoid situation that multiple applications can be chained and make requests between each others. So as a result, so each application will need to have some additional authorization layer if we would like to enforce it everywhere. It will totally increase the cost for AVP because if we're making millions of requests, so if we would like to authorize each request, so the cost will increase dramatically, and also latency. So there were some questions. So like how we can handle role-based access control for each app, like how easily we can roll up to multiple applications. And the last part, how we can handle caching requests, because it's the crucial part of that. So starting from the Terraform AVP infrastructure, so similar, we have identity, we have some actions, so all HTTP methods, and the resource is endpoint. And also we have some identity, still we have relation to role, and also we can see that for endpoint we have path, and you will see why. So in case of policies, so mostly three types of that. The first one, just to check whether principal have the specific role, so it can access it. Also some specific role just for the testing, so the particular path to be tested, like configuration check. And the last one for some specific operation we might have, so like when we have path like it's /API/v123, and we would like to only authorize the all resources which is nested under specific path. So we just checking with like operator. And you might think like, why exactly, Daniel, why can you just use the policy like this, that you checking the resource, because you know that the resource will be some ID and stuff like that. So there is no support for wildcards on entities IDs, which means as a workaround, you need to create extra attributes which you need to fill each time to pass information about your path because of the limitation of CDR. So now how we use it. So for the authentication purposes, we have a Ruby gem, so library, which is our middleware which is used by all resource servers, and it's just handling OAuth for us. So it's validating JWT tokens, it's making retries. It also has some helpers for unit tests and so on. So typically what we do, so we have our authentication service, we're making requests, and it generates JWT token for us so we can reuse it. So we started to think like where to put this logic, and we came to the conclusion that we should just enhance token house, which means that it's not also handling the JWT token generation, but also deal with authorization. So use our SB authorization gem. So what we've done, besides some initialization modification, we created the token house YML file for each and every application, when we can define which endpoints should be authorized or not authorized. Also, which policy store will be for each stage, whether it's for development, integration, staging. Also, if we would like to quickly roll out only to staging, so we can pass authorization enable flag as true or false. Depends whether we would like to go live immediately or go for staging first, or maybe only integration. Also, maybe for some development environment, we would like to use real AVP and not the CDR one. So it's all in this file, and then automatically in our token house library, it knows what to do. So again, we use the backstage template. Again, the Terraform, also some configuration for Elasticache, CDR policies, alerts, and many, many more. Also option whether we're using Ruby on Rails framework, because then the initialization will be a little bit different. So where are those 50 million requests? Because you might think maybe it's just the clickbait for the presentation title, but it's not true. The data from the New Relic. So monthly we have 50 million requests. Majority of that is just for one big internal system. So we can see that we have some internal system, which endpoint it uses, and which service name it's used over there. So let's talk about the cost, because it's the most crucial part about the AVP, because it's quite expensive service. I'm not gonna lie about it. So in AVP, you're paying for the authorization request. So for the first million authorization requests, you will pay $150. So let's do some math. So let's try to estimate our use case. So 50 million requests. So basic math. So for the first 40 million requests, we're paying $150, and for the next 10 millions, it's like split in half. Yeah. So if we calculate it, so yearly it will be 81K thousand of dollars, which is enormous amount of money just for the authorization request, isn't it? Yes. So we starting to use cache. So we use our SB authorization gem again. So the same that we checking all the attributes, create cache keys and stuff like that. So we're starting to see in our dashboard that how many of the requests we're reading from cache and stuff like that. And one day we open the verified permission costs and we check that we hit over $100 per day on Monday, September. So if we check it, if it will be stable number, it will be 22K yearly, which is still enormous amount of money. So we started to think, okay, how we can improve cache. So what we saw that we have path likes, we have some V1, we have some resource, and we have some IDs within the path, which means that if we have individual IDs, it will be cached one and will be never reused. And the rest of the attributes are the same, just this ID is different. So we don't really care about those IDs in path. We care about all the attributes, the path, which role it has. So what we've done, we just use regex to clean it up. So if we have ID, some policy number, UID, XID, and so on, we just adding this ID over there, and we implemented it, we released it, and we started to see that the number of non-cached has dropped, and also like percentage requests from cache per server increased dramatically. So we checked the bill again, and after a couple of days, it was just $4 per day, even less, which is like, wow, compared the whole month. So now it's like not even $2,000 per year, which is acceptable for us. So we can see that this 93% reduction in cost in case of AVP, which is quite nice. But you might still think, okay, you're using cache, so most likely you need to pay for the Elastic Cache. But for the Elastic Cache, is like daily cost was like $5 or so, so still much better compared to the original price of AVP. So lesson learned from that process. Backstage template for quick rollout was perfect for 20 repos because we can do it immediately. Enhancing token house was a good choice because we don't need to create something new. We just reuse something which we know is good and we write it ourselves. Cache is the king, that's true. So AVP could be very costly because also if you touching the application which you don't really know, you don't know how many requests it has, it's like your responsibility in case of the ownership of the application, so you don't really know like what path it has and stuff like that. It was very hard to do proper cache from the beginning. A lot of files to be added because Terraform, some configuration, alerts, new relic dashboard, and so on. So the last part, the learning. So learning tool. So I created the AVP CLI. It's for you to play around with AVP. I created some blueprints that you can immediately deploy to your sandbox account of AVP. It also supports all actions in AVP. So if you would like to play around with that quickly, to check some couple of examples how you can organize your policy store, how to build payload, you can easily do it. There are also some tests over there, so feel free to use it anytime, but don't use it on production. And also to learn more about CDAR and verified permission. So I created the blog post series, like 17 articles about CDAR, AVP, different use cases, features, how to use it with Cognito, with IDPs, and so on. Also, there is now a very nice article about the automated reasoning, how it's used in CDAR. So I really encourage you to read it. And also to watch the GitHub organization for CDAR, because it's open source. So you can take a look what is inside and what is on the roadmap and stuff like that. There is also Slack for CDAR, when you can talk to the folks from AWS, ask some questions, or just talk about the authorization. And that's it. Thank you very much. Go build. And that's all for today. If you have any question, I will be here. You can also contact me, send some LinkedIn invitation, and also please make a survey in the mobile app. And thank you very much. That's all.